In this video, we're going to take a look at transformations of functions, but now we're going to go on to include reflections, stretches, and shrinks. We're going to specifically in this video look at what happens to the general graph. All right, so let's start off. You have this handout where we've got all these rules and we haven't filled these in yet. And so let's do that. When we have y equals negative f of x, we can see the negative is on the outside, which means it's going to affect the sign of y. So if you think of, if I have some point like say up here, maybe that's 2, 3. When I make my y negative, I end up down here at 2, negative 3. And you can see that the reflection kind of has a vertical motion, but we actually reflect over the x-axis. So this first one is a reflection over the x-axis. Our next one is going to make our x change sign. And when we switch our sign on x, let's say we have that same point about 2, 3 here, then it's going to be negative 2, 3. And you can see when we do the reflection, it's like a horizontal reflection, hence it being inside, and we would say that this is a reflection over the y-axis. So the horizontal vertical movement has more to do with the reflection than what line it's going over. All right, now we go down here and we're multiplying by c on the outside in both of these. The difference is if we multiply by a number bigger than 1, then we have a vertical stretch. And sometimes we like to say times c, because that's what we're doing, we're multiplying by c. Whereas when we have a number between 0 and 1, then we have a vertical shrink. And that means that it's going to get divided by c. In this next one, it's on the inside, so it's going to be horizontal. But remember, everything on the inside does the opposite of what we would expect. So when we multiply by a number bigger than 1, we're actually going to shrink. So we have a horizontal shrink, or it's going to divide by c. And over here, when c is between 0 and 1, it's going to be a horizontal stretch, or we're going to multiply by c. Oops. Horizontal stretch, multiply by c. All right, so let's go to some problems. The next problems we're going to look at are actually problems included in your homework assignments. So as you write these down, you can include them in today's assignment. The first one we're taking straight out of the book is number 54. And you can see they give us this graph, and we've got parts A, B, C, and D. So if I was doing this in my textbook, I'm not going to have that graph there. So I'm not going to write right on the graph. And I'm going to start off with A, and I can see that, okay, this is going to be a reflection over the x-axis based on the note sheet we just did. And I can see I'm going to do negative f of x. That means my y value, which is f, becomes negative. So my first point is not going to change, and I'm going to just graph these on here. But my first point, negative 4, 0, when I reflect it over, is still at negative 4, 0. My next point, negative 2, 3, is going to reflect down to negative 2, negative 3. My point 2, 1 is going to reflect to 2, negative 1. And my point 6, 1 is going to reflect to 6, negative 1. And I want to just point out that this is kind of the work we're expecting in your homework, is that, there you go, that you label your points. And that'll work just fine. All right, so in part B, and sometimes it's easier just to keep these all on separate graphs or else it gets messy. If you want to put it on one graph, that's fine too. We're going to do the reflection over the y-axis. In this case, what we're doing is we're changing the sign of x. So now my points go like this. That negative 4, 0 becomes 4, 0. That negative 2, 3 becomes 2, 3. 2, 1 becomes negative 2, 1. And 6, 1 becomes negative 6, 1. And there it is. Let's just connect all of this. And we've got the graph. All right, our last one, C, has 3 times f of x. So when we do C 3 times f of x, that's going to be a vertical stretch. Or we're multiplying by 3. So let's do this, and we want to we're going to have to get this a little out of room, so it might not be quite as easy, but we're going to multiply the y value by 3, okay? So this is basically saying 3 times my y value. My x value stays the same. So negative 4, 0 is still at negative 4, 0. No change there because 0 times 3 is 0. Negative 2, 3 is now going to go all the way up to negative 2, 9. 2, 1 is going to go up to 2, 3. And 6, 1 is going to go up to 6, 3. Notice the x values stayed the same, but I multiplied all the y values. And so we get something like this, which doesn't look as dramatic if I put it on here. So let me just put it on here for a second. If I go up 3 and another 3, this is where that point ended up. So way up here, and then I come down to 2, 3, and 6, 3. And you can see how this thing was stretched vertically. All right, last question, f of 4. Just so that we can see what's going on with our original function, let's look right here. And when we are doing f of 4, we are saying if my input is 4, what is my output? And there's my point right there. And so for that last question, we would say f of 4 equals 1. Remember, my input is my x, and my output is my y value. And so I just look for that point on the graph. So I went to my input of 4, and I went up to my graph, and I said, oh, my output there is 1. All right, the next problem we're going to do is number 58, and we have this graph right here. And our first question asks us about f of 2x. So when we do f of 2x, we are going to actually horizontally shrink. So horizontally shrink. And I think to get a good picture of this, I'm going to do something that I know you guys can't quite do on your notebook paper, but I think it'll help this make a little more sense as to what's happening. I'm going to take a picture of this graph here. Oh, that was loud. All right, and I think we're going to use this a few times, so I'll just clone this a few times for the other ones. All right, so I've got a picture of that graph, and we're going to do part A, that horizontal shrink. And when we shrink, every x value is going to be half as big as it was before. So this one over here at negative 3/2, 0, we're going to go to halfway. Oh, that's not that one. That's, sorry. Let's try that again. Actually, I'm not going to worry about the points here so much as seeing that every point is halfway. So this comes in halfway. This point comes in halfway. This point comes in halfway. Oops, this one comes in halfway. And this one comes in halfway. And same thing here. They all get closer to the y-axis. And so when I'm done, this graph goes like that. And this point right here, this far end, which before was at negative 2, it's at negative 1. And this end that before was at 2 is actually just at 1. So my graph now, rather than going from negative 2 to 2, is actually going from negative 1 to 1. All right, let's try the next one. All right, so in our next one, we have y equals f of negative x. So let's see, that means my x changes sign. So this point lands over here, and this point lands over here, and this point lands over here, and this one here, and this one here, then this point lands over here. You can see that it's landing on itself, and when we're done, we have the exact same graph as before, because when we reflect over the y-axis, nothing changed because it landed on itself. All right, let's look at our third one. y equals 3 f of x, that one is going to stretch it by 3 vertically. Now it's going to stretch up and down. So you can kind of think of this as something it's attached at 0 because 0 times 3 is 0. But all of these others are going to go 3 times as high. So this one that has a height of 1 is going to go all the way up here to 3. The one at 0 stays at 0 because 0 times 3 is 0. Down here at negative 1 is going to go all the way down here to negative 3. So that's at negative 3. This is at 3. The one at 0 stays. This one goes up to 3. At 0 stays. This one goes down to negative 3. Stays at 0. This one goes all the way up to 3. And when we connect these, you can see that this is my new graph. Oops. All right, so I want you to see it's no wider, but it's just, and it goes higher and it goes lower, but anything at 0 is anchored and stays right on the x-axis rather. All right, the last question, D, asks us about the symmetry, and we should show that all of these were even. Okay, every single one was even because the y-axis was a line of symmetry in every single one of these cases. All right, we have one more problem that we're going to try and get done, and this is this one right here where we've got 4 points and we're doing each of these. So this is number 62 and we've got f of 2x. So in this first case we are going to have a horizontal shrink. And when we do our horizontal shrink, we're going to be cutting it in half. So this point at negative 2, 2 is going to be at negative 1, 2. This point at negative 1 is just going to be at 1/2 negative 1. The point at 0, 2, the x stays the same. When I take half of 0, it's still there, so I'm still right there. And the point down here at 2, negative 2 is going to be at 1, negative 2. And so you can see how this graph is just a really skinny version of this one. Or if I did it on here, it basically did that. Okay, and you can see it over here. Oops, I was supposed to come all the way down to negative 2. So let me just... All right, so I kind of fixed up this graph to include all of those coordinates. All right, let's move on to our next one. And that is going to be choice B. And B has two things happening to it. First, we're going to do a horizontal stretch. That'll be easier. And then we're going to go down 1. So horizontal stretch, down 1. All right, so here we go. And when we do this, so that means that horizontally this negative 2, 2 is going to go all the way out to negative 4, 2 and then down 1. So it goes negative 4, 2, then it goes down 1. So it's actually going to be negative 4, 1. So we go over here, negative 4, 1 is our first point. This one, we're going to, again, double it. So first I double, and then I go down 1. So negative 2, negative 2. So there we go. Negative 2, negative 2. And then this one here at 0, 2 is just going to go down 1 to 0, 1. Because remember, if I double 0, it's still 0. And this one I double and go down 1, so I'm going to first double, 4, negative 2, and down 1, 4, negative 3. So 1, 2, 3, 4, and negative 3. And there we go. All right, the last one I'm going to have to leave off so this video, it doesn't get too long, but we're going to have a vertical stretch, and this one will also go down 1. So when we have that vertical stretch, it's going to go higher, but then shift down 1. And I'm going to leave that one for you guys at this point.